You know, in this incredibly crowded world of AI, it feels like a new, more powerful model drops every single week. But Anthropic's Claude is taking a very, very different path. They're not just chasing raw power, they're building on principle. So, what does that actually mean for the future of AI? Let's dive in.
And that, right there, is the central question. While pretty much everyone else is focused on just building the biggest possible brain, Anthropic is making a bet that for AI to be truly useful, especially in high-stakes situations, the real advantage is building something you can rely on, something that's safe from the ground up.
Anthropic's whole philosophy is that trustworthiness can't just be a filter you add on at the end of the process. No, it has to be an architectural feature, something woven right into the very fabric of the AI itself.
So, this is Claude's secret sauce, constitutional AI. The best way to think about it is like a built-in moral compass. Instead of just relying on external rules to stop bad outputs after the fact, CAI gives the model an internal set of principles to guide its behavior from the very beginning. And look, this constitution isn't just something they made up. It's grounded in globally recognized standards, like the UN's Universal Declaration of Human Rights and industry best practices. This creates a really transparent, auditable framework that's designed to make the AI helpful, honest, and harmless. So, how do they actually get this constitution into the AI's, head? It's done through a really unique two-phase training process that's frankly pretty brilliant. Okay, so in the first phase, the model is literally taught to critique and revise its own answers based on that constitution. Then, and this is the really clever part, in phase 2, it learns from feedback generated by another AI that's also being guided by the same constitution. This lets them scale up the oversight in a way that just isn't possible with human-only feedback. Now, building a safe AI is one massive piece of the puzzle, but making it efficient and reliable for complex tasks, that's a whole other challenge. And this is where Claude tackles a huge, kind of hidden problem that plagues almost every large AI model out there. It's called context rot, and honestly, it's a lot like our own brains. Just like a person has a limited working memory, an AI's ability to accurately recall information gets worse and worse the more you stuff into its context window. It starts to forget things, and its performance just decays. So Claude's answer to this is an awesome feature called skills. Instead of the old method of wastefully loading every possible tool into memory, Claude's skills are like a smart contractor who only brings the exact tools needed for the job at hand. The efficiency of this is just remarkable. It costs a tiny 30 to 50 tokens to load a skills description. That's it. This preserves the AI's precious working memory, which allows it to perform these really complex, multi-step tasks with far greater accuracy and reliability. And this whole philosophy of safety and efficiency, well, it extends to their entire product line. It's structured less like a single giant AI and more like a specialized toolkit. So you've got Haiku for speed and keeping costs down. Then there's Sonnet, which is your versatile workhorse for agentic tasks, where it has to take on multi-step problems by itself. And then there's Opus for the most complex expert-level reasoning. This tiered system lets developers pick the right tool for the job so they're not wasting resources. But does this deliberate focus on safety and efficiency actually translate into better performance? Well, the benchmarks say yes, especially in these high-stakes tests. Let's start with advanced math. In a domain that demands precise, complex reasoning, Claude 4 Opus scores a solid 90% on the AMI benchmark, taking a measurable lead over its top competitor. And remember that architectural investment in skills we talked about? Well, this is where it really pays off. On SW Bench, which tests an AI's ability to act like an autonomous software engineer, Opus again takes the lead, proving it's superior at solving real-world coding problems. And finally, let's bring it all the way back to where we started, trust. On the Harm Bench safety evaluation, Claude 3.5 Sonnet achieves an industry-leading score. This is the hard data, the quantitative proof that constitutional AI isn't just a nice idea. It delivers tangible, superior safety results. So what does this all add up to? The strategic goal here isn't just about building a bigger brain. It's about engineering a more reliable and efficient partner, one that can perform complex, long-running tasks for us. So for anyone looking to build with Claude, the takeaways are really clear. You've got to use skills to maximize efficiency. You should integrate compaction, a technique for summarizing long conversations, to manage that long-term memory.
And for tasks where you absolutely cannot be wrong, use extended thinking. It lets the model take more time to think before answering, trading a little speed for maximum accuracy.
And that leaves us with a final thought. As these AI systems become more integrated into our work and our lives, acting as our co-pilots, the most important question might not be who has the biggest model, but who has built the most trustworthy and reliable partner.